Hello friends, myself Dr. Mousumi Karmakar, Assistant Professor, Department of Electronics and Communication Engineering, Mallabhum Institute of Technology, Bishnupur. Today I will give a brief idea of engineering optimization. Nowadays, optimization becomes great importance in practice, particularly in engineering design, scientific experiment and business decision making, etc. The term optimize is defined as to make perfect, effective or as functional as possible. Basically, it is an act or methodology of making something fully perfect, functional, effective as much as possible. In definition, we can say an optimization is the act of achieving the best possible result under given circumstances. Moreover, it refers to finding one or more optimal solutions, which refers to extreme values of an objectives. Now the question arises, what are the goal of optimization? The goal of finding optimal solutions of any optimization problems are minimization of cost with maximum efficiency with minimum time and improve the process with maximum throughput. So these are the goal of optimization. We know that every optimization problem associated with one or more objective functions. The objective function can be expressed the main aim of the model, which is either to be maximized or minimized under given circumstances. For example, in a manufacturing process, the aim may be to maximize the profit or minimize the cost. Optimization problems can be classified based on some parameters. The parameters are problem types and variable types. Again, the problem types are categorized into two categories: constant optimization problem and unconstant optimization problem. Depending on the variable types, optimization problems are again categorized into two categories: dependent variable types and independent variable types. Basically, constant means the restrictions that must be satisfied to produce an acceptable design, and the variables are the set of unknowns which controls the values of objective functions of a optimization problem. Let's go to the statement of optimization problem. Here we see that fx is an objective function that we want to minimize, and it is a function of x, where x is a n-dimensional vector called the design vector, subject to certain constant value that are gix and ijx. They are known as inequality and equality constant respectively. And the constant have some limitations. Here we see that I varies 1 to m and j varies 1 to p. These are the limitations of gix and ijx. In past, classical optimization methods are used to solve the problem, and it is analyzed by using graph and calculus. Here we see that y is a function of x, where x is a single independent variables. Now if the function is represented in two variables, then we can write y equal to function of x1 and x2. In the method of graphical representation, a simple graph of response is plotted in y-axis along with independent variable in x-axis, showing a line with certain minimum and maximum values. In classical optimization method, with the help of single derivative and double derivative of objective function, we can find out the extreme maxima and minima value. Nowadays, evolutionary algorithms are used to solve many real-life optimization problems because of some limitations of classical optimization method. First of all, the classical optimization method are not applicable for discontinuous and non-differentiable functions. And we know that many real-life problems cannot be represented by continuous and differentiable form. Moreover, they are too complex to represent either in equation form or in continuous or differentiable form. So Classical methods are fails to solve this type of problem. Moreover, most of times convergence leads to suboptimal solutions, and the convergence to optimal solutions depend on initial conditions. Classical optimization method cannot be efficiently used in discrete search space as well as in parallel machine. So in this regard, the evolutionary algorithms are developed to solve the optimization problem. And the term EA stands for class of stochastic optimization method that imitate the natural evolution process. Since 1970, several evolutionary algorithms has been proposed, and genetic algorithm is one of them. GA is basically a search and optimization technique which imitates the behavior of natural selection and natural genetics. It is a method to solve optimization problems which are not so far completely characterized or too complex to permit the full characterization, but for which some analytical estimation or physical interpretation to evaluate the performance of a solution is accessible. Genetic algorithm operates on particularly population of solutions by using the principle of survival of the fittest to create a better approximation to a solutions. Let's summarize the whole things. In any optimization problem, at first identify the problem associated with model design or maybe any real life problem. Then choose the design variable and their boundary conditions. After that, formulate the objective function and formulate the restriction or constant values. Finally, choose the suitable optimization algorithm to find the best result. Thank you. Thank you for watching the video.